Okay, these are the notes for Algebra 6-4, and we are going to simplify, hold on, it's blurry, simplify, rewrite, and evaluate rational exponents. Rational exponents. If you notice, rational, the base word is ratio, which means it's written as a fraction. It's a ratio. So like 1/3, 2/5. So when we see rational exponents, we're going to actually see a fraction for the exponents, okay? A lot of people think you're just going to divide. They think 9 divided by 3. Well, that's not what's happening. So I'm going to have you use your calculator. I'm going to show you a key on your calculator, depending on what type of calculator you're using. So first of all, we learned in another unit that you can use the XY, this YX key here, to have any exponent. So if you had like 5, let's say 5 to the third power. So you had 5, then YX 3, that would have 5 to the third power. Now, if you look above this one, there is the second key. I'll show you how to use this. So above this, it says y into the x power here. This is called the index, and I'll talk about that here shortly. If you just want to square root, so let's say you had 100, oops, I probably have to do this first. The square root of 100. Nope, maybe not. The square root of 100, that just means you're looking for what number times itself gives you 100. If you don't want the square root, but you want a different root, then you can use this key. So here's how this is going to work. Now, I know on the other calculator, so you want to look for anything that has a y and an x where you have a different, the variable outside the radical sign. So if we had 9, the third root of 9, so you're looking for a number times itself 3 times to give you 9. Well, there's not a whole number that does that. So this is how you work this. You're going to do 9, the second key, because you want the one up there, 3 equal. And that's approximately, just due to the nearest hundredths is fine. So approximately 2.08. Okay. So again, this is how I did that. I did 9, the second key, because I need the ones up above. It's like a shift. It's like you're capitalized. 3 and that. Okay. Then 9 and 1/3 here. If we did that on a calculator too, which 9, I don't even know if I know how to do this on here. 9 and, oops, clear. 9, I don't know if I can do a fraction. Anyway, oh yeah, no. Anyway, this is going to be 2.082. Anyway, so, but I'm going to show you what happens. This third cube root of 9 and 9 to the 1/3 are actually the exact same thing. So I'm going to show you how you can take the radical form and change it into a fractional exponent. So we call this the denominator, which actually this is called the index. If you can also write that down. This is called the index. That lets you know what root you're taking. Your number here that's inside, this is your base. Now your m here, this power of m, is actually going to turn out to be your numerator when we write it as a fraction. Okay. So if it's written this form, you're taking the nth root. We'll explain that. Here's your base and here's your numerator. So I'll explain that here in a moment. Now, if we want to rewrite this, this is the exponent in Radicand form. So I should tell you this. This is your Radicand. This, it looks like a square root sign. This is actually called a radical. So if they ever say simplifying radicals, that's what it means. So we can't really call it a square root because we're not always taking a square root. We can take the third root or the cube root. We can take the fourth root. So that symbol itself is a radical. The index, what root we're taking, the base. This is going to turn into the numerator, and that's going to turn into the denominator. So this is the exponent. In the Radicand. Okay. So the exponent in the Radicand is this one. Your base, and this is your base. In this whole Radicand, this is a Radicand. Base in Radicand. Okay. And then this is your, like I said, this is your index. That lets you know what root you're taking. So we'll do some practice here. So in words, so the way you would say this, the nth root, so let's say that's a 4, the fourth root of b, whatever this base is, raised to the nth power. Okay, I know right now it seems crazy, but we'll get it. So if the denominator is 2, our exponent form is x, because we don't know what this number is, and then 1/2. In radical form, it'll look like this. So 1/2 and the square root of x are the exact same thing. These equal each other. So if the base is x, the denominator is 1/3, or 3, excuse me, that's 1/3. That's the same as cube root. Okay, so the fourth, so it's going to be 1/4. This is saying the same thing as the fourth root. You're looking for what number times itself 4 times. That gives you, whatever that is. Okay, so the fifth be the fifth root of x, the sixth, so these fractions, sixth root of x. Then at the nth, like we don't know, it's going to be 1/n, and this would be the nth root of x. Okay, so when you see a fraction as an exponent, what's happening is that denominator is your index. Okay, now we're going to work on some that when the numerator is not 1. Now the reason we didn't do anything with the 1 is because technically we're saying this then to the first power, this then to the second power, this then to, to the first power, sorry. All of these would be to the first power. And that doesn't change anything. That's why we didn't we didn't do anything with this 1. But we're going to look at some that they have a different numerator, which is going to make a difference. Okay, so let's look at this one. Operations with rational exponents. Now think back to everything that you've learned so far with exponents. We were multiplying and we had the same base. You want to add the exponents. Okay, so you're going to add, 1/2 plus 1/3. Now don't forget about fractions. You can't just add straight across. You got to have a common denominator when you add them. So the common denominator is 6. The least common denominator is 6. So that's going to be 3/6. Because I'm multiplying this by 3, I'm multiplying this by 2, and this is going to be 2/6, which is going to be 5/6. Now, so this is going to say x 5/6, which in radical form, you're going to take your denominator, that is going to be your index. Your numerator is going to be your power. So this is your final answer. So the sixth root of x risen to the power of 5. Okay. Okay, now this one. This is power of a power. So you're really saying 2 to the 5th. And then you're saying v, now 1/2 times 5. 1/2 times 5 is 5/2. Now 2 to the 5th. 2 to the 5th would be 2 risen to the 5th power, and be 32. Okay, so that'd be 32. V 5/2, so that's going to be now the square. Okay, so when you have a 2, you might not see, this is automatically assumed that there is a 2 for the index. Oops, sorry. Automatically assume 2 for the index. So you might not have it. If you want to go ahead and write it, that's fine. I'm okay with that right now. But all of this risen to the 5th power. So you're going to take your denominator. That's going to be your index here. And risen to the 5th power. Okay. All right, now we're dividing. We have the same base and we're dividing. So remember when you divide, you subtract the exponents. So you're going to have 1/3 minus 1/6. Now you want common denominators, but notice 3 does go into 6, so I just only have to change this one. So this is going to be 2/6 minus 1/6, which is 1/6. So that's going to be C 1/6. So then as in radical form, that's going to be the 6th root of C. All right. Okay, so let's keep going. Now we're multiplying. So you're going to do 3 times 2. Okay. And you're doing n 1/4 plus 1/2. Because you're multiplying these, that means you're going to add those exponents. So you're going to have 6. Now 1/4 plus 1/2. Okay, if you want to get a common denominator, now 1/2 is 2/4 plus 1/4. So 1/4 plus 2/4, that's going to equal 3/4. On that one, you might not even need to do that one. So n to the 3/4 power. To rewrite this, now the 3/4 is only attaching to the n, not to the 6 also. Okay, so you're going to have 6, then the 4th root of n risen to the 3rd power. Okay, so the 4th root of n risen to the 3rd power. So if you had to simplify this, you would do all this first and then multiply by 6. Like if this was like 81, if n was 81, 4th root of that, and then risen to the 3rd power times 6. But right now we're just simplifying. Okay, same thing here. So that's going to be 6. Now the y, there's no y anywhere besides that one, so we have to bring that down. 1/2 plus 1/5. No, excuse me, half. 2 plus 1/5. So 2 plus 1/5 is 2 1/5. Okay, so now think about this. 2 1/5. Well, if we have x and 2 1/5, like it's like, wait, which one's our denominator? Which one? So write this as an improper fraction. So you're going to have x is 11/5. So it's going to look like this. 6y, the 5th root of x risen to the 11th power. Okay. Power of a power. So we have x. You're multiplying. 5 times 1/3 is going to be 5/3. So you're going to have the cube root of x risen to the 5th power. Okay. All right. So here, now make sure you don't do 10. You're saying 5 times 5. You're saying 5 squared. And x 2/4, which is 1/2. So you're saying 25 x to the 1/2 power. So you're going to have 25, the square root of x. So a lot of time, oops, I don't know why I'm doing that. Forget that. But you don't have to put that 2 there. It's redundant because just the symbol itself, the radical symbol, it's automatically there is a 2 there. If you put it there, that's fine. Okay, we have 16 divided by 16 1/2. So you could, this is like a 1 here. You could subtract, or we can go ahead and simplify this, which I would do that. This is 16. Now 16 to 1/2 power. 16 to 1/2 power means you're taking the square root of 16, which is going to be 4. 16 divided by 4 is 4. So there's no variable, you can go ahead and simplify this, which hopefully we can do more of. But you're simplifying. So 16 and 1/2 power is the square root of 16, and you can simplify that. All right, this one, 6a to the 7/3 and 3a to the 2/3. Okay, so 6 and 3, divide that, that's 2. And then a, now you have 7/3 minus 2/3, which is 5/3. So you have 2a and 5/3. So you have 2, the cube root of a risen to the 5th power. Okay, and then here, these are really good to keep and remember about the different rules. They just have the algebraic format of it. So these are excellent to keep handy.